Hello, hello, and good evening, everyone. Hope everyone's doing well. Thank you so much for joining Circuit Stream's Intro to Game Development in Unity. We're super excited about this workshop. We've never done this workshop in company history. We can't find any similar workshops out there like this. So we are super excited to have you join our first ever Intro to Game Dev in Unity workshop focusing on building a Tetris-like game. I can see that most of you on the right side of the screen there have discovered the chat box already. That's awesome. Feel free to say hello, share contact information, drop your LinkedIn profile. We are all a community of learners here, and we would love to get you involved in each other's networks and collaborating in Unity. My name is Kyle. I'm going to be your host and narrator this evening. More on me in just a few moments here. Before we dive into anything further, though, can somebody please let me know? How's the audio? How's the video? Is the sound okay? Can you see the screen okay? Just want to confirm. Oh, Zachary, it's beautiful, you say. Well, appreciate that. I'm sure that the Yeti mic here, the people who create it would be very happy. A couple housekeeping items. I do want to go over just a few housekeeping items, as I said, just to make sure that we're all up to speed. First, let's talk about the interface. We use a program called Livestorm to host our workshops. Few key features I want to call out. So first is obviously the chat tab, right side of your screen. If you ever do have difficulty seeing what's on the screen or anything like that, if it does get a little bit laggy, feel free to collapse the chat tab over there to make your screen a little bit bigger. It's usually not an issue when we're hosting these workshops, but sometimes the bandwidth is a little bit restricted. So try that. Try refreshing the screen. It should be okay. At the top of the chat tab, there's a few more that I want to call out. First is the questions tab. So we have a massive audience this evening. I believe we have over 1,000 registrants. So to keep things organized, I would ask that you please paste all questions into the questions tab at the top of the screen. I do have a few colleagues of mine backstage that can answer these periodically throughout the workshop. But you should also know that at the end of the technical presentation, at the end of my wrap-up presentation, we will be doing a live Q&A session. So this will just help us keep on track of everything as we go. The last thing I want to call out just beside the questions tab is the polls tab. Actually, I need to add a question here to this polls tab that I totally forgot to do. So this is a good reminder for me as well. Throughout the workshop, we would like to gauge the audience, assess who is where, how we've done. Tonight, I actually only have one poll for you guys, and it's really important for us, the Circuit Stream. I am going to ask you about your experience in this workshop. This one really helps us to confirm, should we continue doing workshops in this style with this type of content? So I will provide a warning when there is a poll, but when I do, it would be a huge help if you could all just go on over there and address the poll. It's anonymous and everything like that. So give me half a second. I'm just going to add that draft poll there. Okay, moving on. I always love to do this at the beginning of every workshop just because we have so many international folks. Where is everybody tuning in from? I myself am in Toronto, Canada. It's about 8 p.m. local time. Jerry, who you're going to be introduced to in just a few moments here, he's on the west coast of Canada in Calgary. Just located there, actually relocated from Brazil earlier this summer. I'm seeing Wisconsin, Michigan, go Wolverines, Louisville, Indiana, California, Ohio. Tons of folks here. Awesome to see. Thanks so much for joining. For the folks who are potentially joining us internationally, or for folks who are preparing supper, have a meeting, all of that type of thing, I do want to let you all know. Oh, sorry, Jared, go Bucks. I don't know if I can take your side on that one. Sorry, man. Just kidding. It's all in good fun. We are recording the webinar. This webinar will be recorded. If you have to jump off at any point, don't worry. We're going to send you the recording from today's workshop, the GitHub repo as well, with all of what we're using today in the technical demonstration will be in there. So if you do want to follow along at home in Unity trying to replicate what we're building tonight, you can do so along with the recording. This is going to get asked numerous times throughout the workshop, so I will periodically remind you, yes, this is being recorded. You will get the recording sent to you, even if you don't stay for the whole event today. Obviously, the Q&A session is live, so that can only happen once. So if you do have questions, if you do want to chat, obviously stick around until the end. But yes, it will be recorded. It will be sent to you. In fact, our recommendation is not to try to keep up with Jerry during today's workshop if you already have Unity downloaded. We're moving pretty quick. We're packing a ton of material in today's workshop. So my recommendation, our recommendation, just follow along, ask questions, be an active listener, take notes, do whatever you got to do. But if you want to replicate tonight's experience, do it along with the recording. Okay, with all of that out of the way, let's get started. Hello again, everyone. Once again, my name is Kyle. I'm going to be your host this evening for today's workshop. I am CircuitStream's Enrollment Services Manager. I bring about 4 years of experience spanning across the professional sports and technology industry. A fun fact that I love to share about myself at these workshops is during my time with Maple Leaf Sports and Entertainment back in 2019, the Toronto Raptors were NBA champions. I can officially identify as an NBA champion. I was not on the court. I'm about 4 feet too short, and I lack tons of physical talent. So not a player, but anyways, I am able to say that I'm an NBA champion. Zachary, actually, fun fact here about the word enrollment. That's the British spelling. Here in Canada, we actually spell it with one L. Anyways, not important. Just would love to call that one out. Joining me today, he's backstage right now, Jerry Medeiros. Zachary, you're a funny guy, huh? Jerry's our head of education here at CircuitStream. I hope I spelled that one right there for you, Zach. Jerry is the mastermind behind tonight's project, behind all of the courses, which I'll speak about, that we offer here at CircuitStream. He has a wealth of experience, over 10 years, spanning interaction design, computer science, all the rest of it. He has a wealth of experience. I don't actually have his fun fact up here, but if you've attended a few of our workshops over the years, you will know that Jerry is also an avid scuba diver. Back when he was living in Brazil, I'm sure that this is much more accessible for him than it is now in Calgary, where it's a little bit too cold for scuba diving at the moment. But he is an avid scuba diving fan. He is certified as well. So if there are any scuba diving enthusiasts in the chat, I'm sure he would love to chat with you about that. In terms of a quick agenda, this is all very loose timelines. Typically, our workshops last somewhere between about an hour and 15 minutes to at a maximum 2 hours. I'm going to take about 10 to 15 minutes of your time now, just to introduce the landscape of what Unity is, what they're all about, CircuitStream, who we are, what we're all about, at which point I will be passing things over to Jerry to take over. He's going to do our deep dive technical presentation into Unity. Once he's finished, I'm going to come in and share a few resources, talk about a few of the things that our students have done, the courses that we're offering. There's a rumor out there that Black Friday is ongoing, so we will be talking about some Black Friday deals that we're offering right now. And then, of course, I've promised a question and answer period as well. So that's it. Let's get started. So CircuitStream, who are we? What are we all about? Well, we are an educational company that was founded back in 2015. Hard to believe that it's already almost been 6 years. We focus mainly on education. We noticed a gap in the personalized training and education space in the immersive technology, XR, which is just a fancy umbrella term meaning extended reality space. So to date, we've actually supported over 40,000 individual learners in extended reality and in Unity. These learners have taken part in other workshops just like today and our paid courses that we've offered over the years as well. This is a milestone. This 40,000 learners plateau is a milestone that we're so proud to have reached. Today, we are an international team of about 30 experts coming from all over the world, coming from different backgrounds, coming together to teach folks of really all skill levels about the value of virtual and augmented reality and how to build applications in Unity. Speaking of Unity, I'm going to be saying this word a lot tonight. CircuitStream is a Unity certified training partner. More on what that means later, but for now, all you need to know is that training partners are approved by Unity based on their experience, their focus on quality education, and their commitment to providing the highest level of training available. Beyond that, most of the folks on our team come with various certifications within Unity on their own, certified instructors, certified programmers. Jerry himself is a certified expert programmer. So you have a certified expert teaching you tonight, folks, which is very, very exciting. On the subject of certifications, we actually offer our own industry standard certification, which is tied to international standardization models. I don't want to spend too much time on this right now. We have actually released a pretty lengthy blog post discussing these certifications. Super cool. If you're into this stuff, I would highly, highly recommend that you read the post on this subject. It's chock full of information about how it all works, why it's so valuable, and what it means to individuals and to employers. I'm also proud to announce that actually as of this year, we've been partnering with some of the world's most prestigious universities to offer these educational programs. Our XR Development with Unity program, which I will speak about shortly, is now offered to continuing educational departments by all 4 of these institutions seen on screen. And we do also have plans to offer our interaction design program here at these schools early on in 2022. And we're also launching, I believe, 2 new partnerships in the new year with a few more to follow that. So stay tuned for more information on that front. Again, reiterating this, CircuitStream, above all else, is an educational company. As you can see on screen here, we've had the pleasure of working with some of the world's largest and most exciting companies. And given how quickly this technology is accelerating within the industries, any industry really, the biggest companies and institutions in the world are taking notice and are continuing this innovation process. Now, what exactly is Unity? Well, it's an engine. I'm going to talk about that a little bit later, and I'm sure Jerry will have more to say on the subject as well. For now, this is what Unity looks like. If you've seen this interface, you're most likely already familiar with Unity. And if you've seen the subject matter on screen here, this muffin clicking game, then you've likely already completed our C# scripting fundamentals course. For those of you who haven't seen this, whether the game or the interface, don't worry, we are definitely here to help you out and we will shed some light on this. Again, Unity is a development engine. Ultimately, it's a program that can be used to create both 2D and real-time 3D content, which of course would include both augmented and virtual reality. In our opinion, Unity is definitely the program that's most beginner-friendly if you're looking to begin building your own applications. We also know that Unity's impact is widespread. Today, about 60% of all of the world's AR and VR content is created using Unity, and they're also directly responsible for a massive share of the broader content application markets worldwide. In fact, applications that are developed in Unity are downloaded over 3 billion times monthly. This software is literally borderless, and it has been adopted in over 190 countries globally. The real question that beginners always ask is, how do you actually bring your idea to life? Well, going from left to right here, I'm simplifying this, of course, but this is the general gist of it. Like anything, these games, these applications, they all start with an idea. From there, you need to build your assets and bring them into an engine like Unity to create immersive interactions using scripts in the C# programming language. Once you're built, you need to leverage what's called a software development kit, or SDK for short, to basically ensure that the target device you want to host your application on is compatible with your build. Once you've done that, you render and publish your application, and you have a finished experience. It's that simple. It's not really that simple, but for today's sake, it's that simple. And how can CircuitStream help you get started in this space? Well, we have an academic portfolio of free online workshops and webinars like today, and also a variety of paid courses that we do offer. They're all designed to help students learn how to build VR and AR content in Unity or non-VR and AR content in Unity. These courses are mainly meant for beginners, but we can definitely help more intermediate or advanced students or teams, groups of employees via the custom one-to-one sessions that we offer, or our team training groups, custom groups that work that we can do as well. These are our three main courses on screen here, and let's go from left to right. The left course, the Introduction to Unity 3D Development Program, it's actually our newest curriculum. It's an 8-week project-based course. It is taught live and online, led by instructors just like Jerry, and it focuses on the Unity fundamentals and actually has students creating their own project while they learn. By the end of the course, they will have created and launched a fully completed application. Our first ever cohort for this program actually begins quite soon on November the 29th. The registration deadline for the inaugural cohort has not passed just yet, but it is coming up early next week. Now, if you're looking for XR specific training, we do also have our two flagship courses available to you that we've been offering for some time now. So in the center, the XR Development with Unity course is for developers, while of course our Interaction Design and Prototyping for XR course are for all the design-oriented people in the room. And again, I want to reiterate this. Our course offerings are meant mainly for beginners, but of course we can also support intermediate to expert level learners via our one-on-one catered learning packages or our group training experiences. From our structured flagship development and design courses to our one-on-one mentorship or project-based approaches to education, we offer education in a highly, highly technical field. And of course, we supplement this learning with accessible and ongoing community support to all learners and to all alumni. We offer these courses on an individual or on a group basis. And for any students or learners looking to attend these courses through a recognized institution, definitely consider enrolling directly through one of our university partners. I'm going to talk about them just briefly here in order just to give you an idea of some timelines here. So the University of British Columbia Extended Learning Department will have another cohort for our XR development course beginning in January. And of course, on screen, we actually just had a cohort kickoff yesterday. Same two dates here on screen. If you're in Ontario, the University of Toronto School of Continuing Studies will begin their next cohort in January. And then for our American friends, Indiana Wesleyan University, the Talent Ladder powered by IWU will have their inaugural cohort beginning on November 30th. And finally, in Alberta, the Northern Alberta Institute of Technology, or NAIT, will be offering their inaugural cohort on the same day. Now let's focus on today here. I promised 15 minutes before we move on. What are we going to learn? What are we going to cover? What is Jerry going to teach you? Well, first and foremost, he's going to talk about the Unity editor. He's going to talk about the user interface and the main tools that you need to learn as a beginner. He's also going to talk about prefabs, prefabricated objects, and how to deal with them in these objects within the editor. He'll talk about different types of game objects and how you can use them within the editor. He'll talk about simple game controls, simple interactions. And the thing that everybody's scared of, coding, he is going to teach you some very, very basic, simple scripting and physics within the engine. That's what we're covering today. Again, we will be sending out the recording and all of the assets that he uses today. My recommendation, please do not try and follow along. He, in his own words before the workshop, he told me that today is going to be, quote, intense, end quote. I think there's going to be a lot of content jam-packed here into the presentation. So for now, that's going to conclude my portion of the presentation. Again, we are going to be sharing the recording and the assets with everyone. So for now, what I'd like to do is take this time to invite Jerry up here on stage and just reiterate how much of an honor and a privilege it is to have him join us today. He created all of our courses. He's our head of education. And tonight he is your teacher. Jerry, great to see you. I hope you're
Hello.
very moved there. Take it away.
Great to see you too. Hello, everyone. Good morning, good afternoon, good night. How is everyone doing there? Can you see me and hear me well? Is it okay? Yes, no. Echo? Oh, I'm sorry. Let me try one thing. I've just moved here, so I don't have many things in my office, so that's why you have the echo there. So I just opened the door. Maybe my cat's gonna jump into the table, but well, we can deal with that better than with the echo there. All right, I'm glad it's better. So let's get started. We have a lot to unpack today. So before we jump into Unity, I'm pretty sure you guys are probably super excited to see how Unity looks like and what I'm gonna be doing there. I would like to start real quick here with first what we're gonna be doing, because you know, the Tetris game is very complex. There are scoring systems, music, and everything. We cannot do every single thing that exists in the game in under 1 hour. So we're gonna focus on the main aspects, and then I'm gonna challenge you to keep working on top of that. So what we're gonna do today is working with Unity to create the pieces, and we're gonna just use cubes for that and add colors, position them. We're gonna make the pieces move left, right, down as it moves in Tetris, rotate with the key input, add some constraints so it doesn't go outside of the board, it doesn't go on top of other pieces, and then clear the line when we have a full line. So it's gonna be a lot. Just cubes or colored cubes? Yeah, we're gonna be using colored cubes. So that's gonna be a lot. A couple of recommendations so you can make the most of this. I'm gonna be covering not only the logic and the code, but also the concept. So I'm gonna try to explain what the things are in C#, what they mean in Unity. So try to pay attention to the concepts because they're gonna be useful for you to create your own games in the future. Also the logic, like how I think through it. Like I have this problem, what's a good way to solve that? We're gonna do that as well and see how it goes in terms of translating that to code. I don't recommend that you try to do that now, like that you follow along, because I'm gonna be typing here and there, and if you try to do that, you're gonna miss the explanation. So you're gonna receive the video plus the complete project so you can review on your own pace and pause. So just because it's a workshop, it's gonna be super fast. So if you try to follow along, I think you're gonna get lost. So try to pay attention to what I'm doing and ask your questions. Later on, explore and expand. So the things that I didn't implement here, you can try to implement that as well. You can go to our Slack channel and ask about the questions there, and you can try to add more features and use the time to ask a bunch of questions. So that's my recommendations for you to make the most out of what we're going to be doing here. So without further ado, let's start with Unity. Oh, before this is the finalized project, so maybe that's gonna get you a little bit excited. So this is what we're gonna be doing today, where we have random pieces, we can move them, we can, well, if you're good at this game, we can basically clear the line in there. So that's the scope of what we're gonna be doing today. You're gonna get the code and the project and everything. So let's go with that. All right. So Kevin said the video is super laggy. Try to refresh your page, maybe. There's a lot being streamed here, so sometimes it's not the best, but unfortunately, there's nothing I can do about it. So we need to live with that. I'm sorry. All right, so let's get started. I have the Unity Hub here. If you don't have it right now, don't worry. You can go to Unity and download it at some point. We're gonna be creating a new Unity project. So I'm just gonna hit this button new here. and create a new Unity project. Usually it's gonna ask me where I want to save it, so we can call or add that anywhere. I'm gonna add that to this folder here. You can save that anywhere. There are a couple of templates here for different types of games. This doesn't change almost anything. So if you're making a 2D game, you can select this, but you can change it later. Today, I'm gonna be using cubes, not squares. So I will go with the 3D template. So that's the first thing I'm gonna do. Just create a project here in Unity. And so we have a starting point. All right. Any tips to improve resolution? You mean resolution on I don't know. You mean resolution on the streaming? Not sure. Yeah, maybe what I can do is just reduce the resolution of my display a little bit. Let me see if I can do it. I'm gonna try to do that a little bit smaller, and sometimes it's improved. Let's see what happens there. Is it any better? Maybe it's gonna be a little bit bigger, right? All right, great. So let's get started. This is Unity. If you have never seen Unity before, this is how it looks like. So it's divided in a couple of panels, and each panel is going to have a different function. So let me just cover real quick here the main panels, the ones that we're going to be using more often. So we have this panel that's called Scene. Oh, if you see it different from what I'm seeing, don't worry, we can move it around and you can play around with the way that it works for you. You can close tabs. So it's not gonna look everything. It's not gonna look the same for everyone. It depends on how you customize that. But let's see what the main things are. So the scene is basically the most important window that we're gonna be using today. This is the entire 3D world that you're gonna create in Unity. It's beyond what the user or the player can see. So everything goes here. It's basically your workspace. It's where you're going to be creating your objects and positioning them. On the left here, on my left at least, I have the game view. This one is basically what the user is seeing in the end, because the word is too big for the user screen. So only what is inside of this viewport the user can see. And what determines this is basically a camera, but we don't need to worry about that right now because we're gonna deal with the camera later. But just a difference here, the scene is basically where we position our objects. The game is basically where we see what the player is gonna see. Here on the left in the hierarchy, we're gonna have everything that exists in the scene. So it's very similar to the scene, but instead of being visually here, they're gonna be logically organized. So we can have, for example, one object that is a parent of another object. And if I move the parent, all of the children move as well. So the hierarchy just organizes our scene in a logical way. And we're going to use the hierarchy quite a lot. Everything that exists in our world, we call a game object in Unity, at least. That's how Unity calls that. So everything that exists here is a game object. It can be a camera, a light, it can be a character, it can be a Tetris block, it can be anything. So everything that we create in the scene or in the hierarchy is gonna be here as a game object. Every time I select one game object, here all the way to the right, I'm gonna have an inspector. So the inspector is basically the window where we can change the properties of a game object. So if I select, for example, this main camera, I'm gonna see everything related to this main camera, and I can basically change, for example, here, position, rotation, and whatever we wanna change. So it's gonna be true for every single game object that exists in the scene. We can use the inspector to change them. And last but not least, here on the bottom, I have the project tab. So in the project tab, we're gonna create all of the assets that we wanna use in our project. So what is an asset? It can be an image, it can be a sound, it can be a prefab that we're gonna see what it is in a while. So everything that exists in our project that we can use is going to be in the project tab. I can use the project tab to bring things into the scene. So not everything that exists in the project is being used necessarily in the game. All right, so those are the main tabs that we have here. Of course, there is a bunch other tabs, like hundreds of them, but we're gonna stick to those today because those are the ones that we're gonna be using. All right, does it make sense? Cool. Nice. So let's start with the basics. We want to make a Tetris game, right? So we want to have our Tetris blocks or pieces or whatever they're called. So I was looking into something here, which is basically, they have names. I just found out that they have names. I can't remember them anymore, but this one, yeah, that's it. Thanks. Tetrimino. I don't know how to pronounce that, but they also have like individually they have different names. So this one, for example, is the Smashboard, but the name doesn't matter that much. What matters here is that all of them, we can look here and see that they can be constructed based on cubes. All of them are like basically different groups of cubes, and they have different pivot points that we can use to rotate them around. So we can see here, for example, that in all of the states of this guy, we have the pivot point here. Here we have the pivot point at the center. So we're going to be use that into, we're going to take that into consideration when we are creating our object. So let's start by creating the first one. This one here, that seems a little bit easier. So let's create that one. Let me see the chat here. Is this being recorded? Yes, you're going to receive the recording and the scripts as well. I've been playing Tetris for 28 years. Oh, that's cool. Why isn't the straight block pivot point in the center like the others? Because that causes some rotation issues, and we're going to see that happening in a while. That's because when you rotate, it can go outside of the area. But we're going to see that in place. All right, so let's start by creating one of those pieces there and see how it goes. So here in Unity, as I mentioned, we can use the hierarchy to create objects, right? So I can, for example, right click here. It's going to give me a couple of options of things that I can create. And I can basically go here under 3D objects and I can create what we call primitives. So the primitives are basically shapes, like basic shapes. So we can select spheres, capsules, and in our case, cubes. So we can basically create this cube here. If I want to make that specific piece, which is this one here on the top, I can basically just duplicate those cubes and do something like this. Like if I hold Control D, it's going to duplicate the cube and I can duplicate them. But there is one thing that's better for us to do here, because in this case, if I move this cube down, the other cubes, they're not going to move down too. If I move this one, the other ones then move. And actually, I want everyone to move down together, right? So when I write a script here, I want to make everyone go down together. So instead of just creating them as simple, empty, or disconnected blocks here, we're going to do this in a different way. I will right click, create something that is called an empty game object. So what is an empty game object? It's another game object that doesn't have a visual feature. It's not a cube. It's not a sphere. It's nothing. It just holds a position, a rotation, and a scale in the world. So basically, that's how game objects work. All of them, they have positions, rotations, and scale. So I'm going to call this one, I can't remember the name. Oh, okay, let's make that fun. Let's find the Tetris block names and use the right names. So that's what I was mentioning. There is this game design thing here where they have names. So this one is a hero. So let's just call that a hero. I'm going to rename this game object. So it's called a hero. To rename, I can right click, rename. Oh, no. Right click, rename, and I will call this one hero. So first thing, I will make this into the origin of my word just to make our life a little bit easier. So when we create an object in Unity, like I did here, right click, create empty, it's gonna go to some random position based on where the scene is positioned. So I will make that into the 0, 0, 0. So that's the first thing I will do. And now, consider that I want to make this object fully aligned and everything in the correct position. We can see here that we have this grid in Unity. So I'm gonna click here in a different view. We can, for example, like just change the views here. If we click on this thing, we can basically have different views. So we can see from the top, from the bottom, from the left, from the back, and we can just basically like move the kind of vision that we have here. And I actually want to see it from, well, it doesn't really matter. Let's go with the top. So I want to see it in a way that I can see the grid. So it's just going to make it a little bit easier for us. And now, because I mentioned we want to make this move like all together, now we're going to use the concept of the hierarchy. So I'm going to create the cubes again, but instead of creating them as individual pieces, they're going to be children of the hero, which is an empty game object. So I right click, create 3D object, cube. And there we go. So now look at that. When I select my hero here, I move it, the cube moves as well. If I create another one, so I just duplicated it. If I get the hero and move, it's gonna move as well. So that's the concept of hierarchy. Every transformation that I apply to a parent, it's going also be applied to all of the children. So that's gonna allow us to create code or something that moves this piece, and this is gonna move everything all together. Does it make sense up to here? Does it make sense? Is it okay? Cool, great. All right. So good so far? So it's a container object. That's a perfect way of seeing that, Braden. It's a container object. That's it. So it's gonna work as a container object. Contain all elements. Yeah, that's it. That's it. It's like a folder. Perfect. It's definitely like a folder. All right. So let's continue here with this hero so we can move to the scripts a little bit. First thing that I want to make sure here is that this hero guy is on the 0, 0, 0. So I'm going to move it back to the 0, 0, 0 here. And I'm going to align those objects with the grid. So I want to make sure that when we are creating that object there, they are perfectly aligned. So I'm gonna get like the cube that is more to the left, and I will move it 0.5, or better saying minus 0.5 and minus minus 0.5 unit is here. So it's now aligned to here. This one, I want to move it here. So it's going to be 0.5 and minus 0.5. I will duplicate one more. This one is going to be 1.5 and minus 0.5. And I will create one more. And it's going to be 2.5 and minus 0.5. Why did I make those offsets? Because I want the pivot to be, oh, so actually I did that wrong. The pivot should be here. Oh, that's okay. It should be on the 0. Let's check that out. Just 1 second. Minus 1, 0.5. Okay, so this one should be minus 0.5. This one should be minus 1.5. This one should be 0.5. And this last one should be 1.5. And I'm going to explain why in a while. All right, that's it. So why did I use those specific offsets in there? Because remember that when we had the slide there with the pivot, for this specific object, I want the pivot to be here on the top. So when I select my top here, we can change in between center and pivot. So the center is basically the average position of all of the objects. And the pivot, it changes based on where we position our objects. So considering that I want the position of the pivot to be here, I need to move everyone in a way that they make sense. So this one, for example, could be here. This is going to be minus 1.5 to the left. This one here is going to be minus 0.5. So the 0 point is exactly here in the center. This one is going to be 0.5 positive, and this one 1.5 positive. And the reason why everyone is minus 0.5 down is just so the pivot is not on the center. The pivot is on the top here. So if I get all of those pieces and make this 0, for example, now the pivot is on the center. That's not according to that slide that I had. So that's why I will select all of them and make this a minus 0.5. Does it make sense? So this just creates one pieces with the cubes. And this is the hero guy. All right, so just to fix that, let's create one more. We're not going to create all of them, so we're going to be here doing that forever. But let's create one more so we can reiterate on those things. So let's pick one other shape here. Let's do this guy here, which is called Smashboard. So let's do the Smashboard. I'm going to do a very similar approach. So right now, let me disable the hero so it doesn't bother. It's not on our way. I will create one more empty and rename this one to Smashboard. Position that on the 0, 0, 0. So we're going to have 4 cubes for this one. So let's create here the first cube. This one is going to be positioned at minus 0.5 and 0.5. So it's going to be here on this tile on the grid. I will duplicate this one. I want it to be here. So it's going to be 0.5 and 0.5. Duplicate this one. Oops. I want it to be here. So this is going to be minus 0.5 and 0. Oh, no, minus 0.5. So it goes down. And one more, and the last one, this is going to be positive 0.5 and minus 0.5. So now, if I select the pivot here, it's on the center. Is it possible to create several objects and later add them to empty? Oh, yes, you can. So say, for example, you created this object here, and it's not under the empty, you can just drag it. And it works. And you can select multiple objects and drag them as well. And Kevin, what exactly is the pivot point again? All right, so the pivot point is basically the point we're going to use to rotate around. So here in the hero object, according to that documentation, it rotates around this top here, not the center. So that's why we moved everything down. So we have the pivot point here to rotate around. And in the Smashboard, the pivot is the center. That's just a coincidence. Actually, I think that the first one that we created is the exception. Not really. You see, like each one, they have like different pivot points. So basically the pivot point is where it's going to rotate around. It's basically that. For this object, it's not the center. That's why we moved everything minus 0.5 down. Does it make sense? Are you with me up to now? No problem? Sense made. All right, perfect. Cool. So now let's pause here the creation for a while. We're going to do a couple more things here, but let's now create our first ever C# script. So in Unity, and I saw someone asking there that if we can use Java or other language in Unity. Actually not. In Unity, you can only use C#. So we're going to need to learn a little bit of C# today. Let's go there. So I will create here a folder. So I right-click, create folder, and call it script. That's not mandatory, but it helps us to organize our project and keep everything in place. So I will highly recommend that you have folders for different things. And under the scripts folder, we can create our first script ever. So I will create one script here that I would call piece or Tetris. I don't know how to spell that, so I'm just gonna call that block or Tetris block, something like that. So I will right click, create, and then I will choose C# script here. So every time in the project, when we right click, we have access to all of the types of assets that we can create in Unity. We're gonna create a couple more, but right now it's gonna be a C# script. Then we need to give it a name. I will call this one a block. And that's it. So now I have a script. All right, let's see the anatomy of a script. I'm going to open it and show you how a Unity C# script looks like. So every time that you create a Unity script, it's going to look like this in the beginning. So I hope you're not terrified. It's simpler than it seems. So let's try to unpack what's going on here. First thing, in C#, every script that we create is a class. So what is a class? It's something that we can replicate. It's a template that we can reuse. That's why we created this block as a C# script, because we're going to have many blocks in the scene, and all of them should respond to input. All of them should move down. All of them should have the same behavior. So that's why we are creating a script here that is a class block. So this program is Visual Studio. When you install Unity, it's going to install Visual Studio by default. It's free. You don't need to use it if you don't want to. Well, it's good. It's good for free. Cannot complain. So we're going to be using Visual Studio here. Yeah, get a good old OOP. Yes, that's it. You're gonna see that Unity is not friendly with OOP, but in general, that's it. Cool. All right, perfect. So all the scripts that we create, they're gonna look something like this. You can use VS Code. You can use whatever. You can use code Notepad if you want to. Don't recommend, but you can use everything. All right, so what are those things that already exist here in this script? First thing, every time you're gonna see that there is this mana behavior thing here. So mana behavior is the base class in Unity that basically just defines that this is a game object. So this is just a standard, every time it's gonna be like that. And then we have two interesting things that already exist here. We have this void start and this void update. What does this thing mean? Everything that we write here in this void start is going to be executed automatically only once when we hit play in our game. So I have a block, the start executes in that block. If I have 10 blocks, the start executes once in each block. So the start is basically like the starting point of our code. We're going to use this to initialize speed, fireball, whatever we need to initialize. So that's the start. The update, it's gonna run once per frame. What does that mean? If my application is running at 60 frames per second, it's gonna run 60 times in 1 second. So the logic of the game should be here. If I need to check, for example, if the user pressed a key, I cannot do it on the start because it only executes once. So the user needs to execute like the key exactly in that moment. But in the update, it happens every time. So everything that we need to repeat, we're gonna do in the update. So typically you need to know or write the code necessarily, but know which elements to code and how to code them. Oh yeah, well, I don't know the context. We can discuss that later, but I would say yes, you need to know a little bit of code. All right, so those are the start and the update. Let's start by doing a very, very simple thing here, which is basically moving our block to the left and to the right every time that we press a key. So as I mentioned, we need to do that in the update because that's the function that runs every frame, right? So we need to do that in the update. There's another statement that we can use in coding, and you're gonna see that coding is like natural language, but with a couple of different rules. I wanna check if something is happening. I wanna check if something is true. So every time that I wanna check a condition, we can use something that is called an if statement. So inside of an if statement here, I need to check a condition. Is this happening? If it is happening, everything that is under the if block is going to be executed. So the if block is basically to verify specific conditions. So what is the condition that I want to check here? Is the user pressing the left key or is the user pressing the right key? That's what I want to check. For that in Unity, we use the input class. So every time that I want to read keys, buttons, accelerometer, GPS, any user input, we're going to use this class. And then in this class, there is a function called getKeyDown, which I need to tell this function which key I want to check, and it's going to tell me if this key is pressed or not. And then we need to specify a specific key code. So right now, what I'm doing is I want to make this block move left and right. So I need to check, is the key code right arrow being pressed? If it's being pressed, whatever I write here is going to be executed. Otherwise, nothing is going to be executed. So I can just copy this and repeat it and change it. Instead of right arrow here, I'm going to check the left arrow. So now, every time that the user presses right, because this is in the update, whatever I place here is going to be executed. Every time they press left, whatever I place here is going to be executed. Does it make sense? I'll go there. Is it harder than you were expecting? Easier than you were expecting? Cool. So now we want to actually make this block move right and left, right? So we're gonna use something here in Unity that is called a transform. So what is a transform in Unity? We're gonna see that every single game object, 100% of the times, they have something called a transform. So what is the transform? It's basically an object in Unity that defines three things: position, rotation, and scale. So every object in a game needs to have that, even if it's invisible, even if it's a container, as we already know, it needs to have position, rotation, and scale, and that's in the transform component. So if you want to move things, we are going to use transform. If you want to scale things and rotate things, we're going to use the transform as well. So let's go back to my script here and see how we can move that thing. I'm going to use a transform dot. There are a lot of different functions that can affect a transform. The one I'm going to use is called translate. That's easy. I want to translate it. So if I want to translate it left, I basically need to tell it that it needs to go vector tree dot left. What is a vector tree dot left? It's basically a vector tree that has -1 on the x, 0 and 0. So it's just like a vector. If I go here on my super advanced tool to draw, we have here x and we have here y. So if I want to have something that points left, it needs to be -1 in x and 0 in the rest of the things. So that's what the vector tree left basically does. So every time that I press, oh, I'm sorry, this should be right because I am in the right arrow. So every time that I press the right arrow, it's gonna translate my transform right. Why would a vector 2 be? So vector 2 is the same, but it doesn't have z. It's just x and y. Use that when you're doing 2D projects. But in 3D, it's always a vector tree because you have x, y, and z, right? So the right here is 1 positive in x, so it goes right, 0 and 0. And here on the left, it's going to be the same thing, but it's going to be the other way around. So instead of right, I want it to go left. Make sense? If you flip your camera angle the other side, would it function in reverse? It would. Yeah. Cool. So now let's test it. If I just go back here and I hit play, what's going to happen? What's going to happen? What do you think is going to happen if I just hit play here? Nothing? Why? It should move? Should move or nothing? Nothing. It didn't apply to the object. Ha! You guys are attentive. That's it. So if I hit play, nothing is going to happen right now because those blocks, the hero and the Smashboard, they have nothing to do with that script. So what I need to do is select my hero, click on add component, and search for my script that I called block. So now the hero has the script block. And I'll do the same with the Smashboard. So I'll click here and add a block. Now if I hit play, there we go. If I press left, it goes left. If I press right, it goes right. So that's the first behavior that we added to our block there. It was easy, right? It's zooming? No, it's not zooming. It's just that the camera is a perspective camera. So depending on how you look into that, it's going to be a little bit different. But it's not zooming, it's just the perspective of the camera. We can fix that later. Cool. So before we apply the gravity, David is quite excited about that. Let's make the rotation so we can see how easy it's going to be. Will the movement always shift in increments of 1? Yes. Why? Because we are using the left and the right, and this is basically what we call a unitary unit vector. It's just one unity here. If you want to make it move more, you could multiply that by 2, for example, or by 3 or by 4. But we're going to rely on moving one by one. It's going to be important for us later. All right, so now let's make the rotation. In Tetris, and the people that play Tetris for 20 plus years there, you know that every time that we press up, it's going to rotate, right? So we're going to do the same thing here, very similar. If input dot get key down, key code, oops, key code dot up arrow. So every time that I press up, I want to rotate the guy, right? We're going to use the transform. Now, instead of translate, we're going to just use rotate. And in the rotate, we need to pass basically how much we want to rotate this when we actually rotate that. So we need to define like around which axis we want to rotate. So I'm gonna use the forward vector. It's gonna rotate around the z vector. So we're gonna say vector3 dot forward, which is basically 0, 0, 1. So it's basically around the z-axis. And then how many degrees we want to rotate it. So I want to rotate it 90 degrees. That's basically how much it rotates in there. Let's play and see how it looks like. Look at that. Every time that I press up, my void just rotates. There we go. It's rotating there. I can still move it. So now there is one problem here that's going to happen. Every time that I rotate this, the forward of this object, where this object is pointing to, it's going to change. So let me replicate that. I'm going to rotate it. So let me get the hero here. Every time that I rotate it, we're going to see that the front of that object is looking to a different direction. So say, for example, I have this, and this is the forward of my block here. If I rotate it this way, now the forward is up. So that's going to influence how the movement works. Because every time that we rotate, we are moving it in the right, but this is the local right. And it changes every time that I rotate the object. So to fix that, we're going to need to pass one more thing here in this translate, which is basically which local space we want to use. So there are only two local space, or there are only two spaces, which is the self, like the space of the object itself, or the word that never changes. We can compare that, for example, with I don't know, like the Earth and a map. If you rotate the map, the north of the Earth never moved. So if you point to the north of your map, it's one place, but the north of the Earth never changed. So here we can basically fix that, saying that we want to translate always in the world space. When you add the script in Visual Design, does it automatically update in Unity also because it applies to the game ops already? When you add to the script in Visual, oh yes, if you save, yes, every time that you save, if you make a modification here and save, it's going to apply to the objects there. That's true. So now that I added the space word here, what's going to happen is I have no problems with that anymore. I can rotate my object and I still move them right and left in Unity. It doesn't matter. It's not going to go to crazy places. All right. Oh, so now we're going to add the gravity. Let me collapse this, and this, and we're going to add the gravity here. So the gravity in Tetris, it works in two different ways. So the first way, the first one is if you don't press anything, it's going to move down, 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 down 1 unity in an interval of time that we can define. And if you press down, it's going to go faster. So we're going to do those two behaviors. So the first thing that we need to account for here is the time. We need to make sure that every amount of time, like interval of time, we're going to make it move down. So to make it configurable, so you can make like a game that is harder, a game that is easier, we're going to define on the top of our class one thing that we call a variable. What is a variable? It's basically a named container for a data that we can change over time. So let's see how it works. First thing, we need to make it either public or private. So when it's public, it means that we can add it there from anywhere, and we're going to see why it's important. When it's private, you can only add that from inside of this script. So let's consider that this is going to be public for now. The second thing that we need to add is the type. Is it a text? Is it a number? Is it true or false? What is it? So if we make it an int, oops, an int, oh, Now it goes. If you make it an int, it's going to be an integer, which is a whole number, basically 0, 1, 2, 4. It cannot be 0.5, 1, like 3.3. It can only be whole numbers. So we're going to call that a fall time. And I will define a default value of 1. So what that means is I am telling that every 1 second, I want this to fall. Every 1 second, I want it to fall. That's basically what we're doing here. And I also need another variable. And this one can be private because we're not going to change that outside, and we're going to see that in a while, which is the current time or the time count, like something. Oh, it cannot be a float. It needs to be. It cannot be an int. It needs to be a float. The difference between an int and a float is that an int is basically a whole number, and a float is basically it can be a floating point. It can be like 0.1, 0.2, and this one can be a float as well. If I want them to call like in 1.5 seconds, we can basically just use a float. This one is going to be the count time that always start at 0. So this one is basically how long I want to wait until the piece or the block falls. And this one is what point in time we are right now. And I'm going to use that to accumulate time. So we're going to be, we're basically make like a clock in this variable. So let's see how we can do that in an easy way here in the update. As I mentioned, the update runs every frame, not every second. So it basically runs every frame. There is one variable that we can use under the update, which is called the time dot delta time. So what is delta time? It's basically how many milliseconds or seconds passed since the previous frame. So if we use this count time to increment that every frame, we can know how many seconds we have up to now. So we start at 0, and then 10 milliseconds passed. In the next update, 20 milliseconds passed. In the next update, 30 milliseconds. So here I have basically how many milliseconds passed since the game started, because it starts at 0, and then it increments every delta time. Delta time is how long it took between now and the previous frame. So that's basically the distance in terms of time in there. And this is gonna work like a clock. It's gonna get 1 second, 2 seconds, 3 seconds, 4 seconds, and that's it. It's gonna basically move this way. Does it make sense? Let me go back to the chat where I can see everyone here. All right, cool. So now how I make this move down, I'm gonna check if the count time is greater than or equals to my fall time. Why? Because if my count time is 5 seconds, for example, it's gonna be 0, 1, 2, 3, 4, 5. It executes. So it means that I need to make it fall. I need to make it go down. And here I cannot forget to restart my count time to 0 again, because then it's gonna be 0, 1, 2, 3, 4, 5. It executes, and then it's gonna go there. I thought you could not change count time since it was private. You cannot change it outside of this script, but inside of this script you can. You can change. Oh, thanks. That's it. You can change it from this script, but not from outside of it. I'm going to show how it reflects in the editor in a while, but let's just make sure we have this. So every time that I have my count time, when we get it to like 1 second or whatever, I want to make the block go down. We already know how to do it. Transform.translate. And here I'm going to do vector3.down, which is 0, minus 1, and 0. So nothing in X, minus 1 in Y, and nothing in Z. And we're gonna use the world space as we did previously. So this should make the blocks fall every interval of time. You're doing the rate exactly. That's it. I'm doing the rate in which the blocks fall. And now let me show you how it is interesting. When I select my hero, and let me disable the Smashboard so it doesn't confuse us. When I select my hero, look at that. My script has something called fall time that I can edit here. Why I can edit the fall time here? Because the fall time is public. But I cannot change the count time there because it's private. So let's hit play and see. It's gonna fall every 1 second. And there we go. It falls every 1 second. If I make this like more time, it's gonna take longer to fall. So if I take, for example, 2, it's gonna take 2 seconds to fall. So 1, 2, fall, 1, 2, fall. If I make it less than 1, like 0.5, it's gonna fall every half a second. So that's why a variable is important, because we can make the game harder or easier in an easy way. Does it make sense? Kind of cool. Nice. So now let's make it accelerate when we press down. We're gonna go there and make it accelerate when we press down. So how are we gonna do that? Well, first we need to check if we should accelerate or not. So I'm gonna create one more variable here on the top. It's going to be private because I don't want to change if should accelerate outside of this script. We don't want to do that. Instead of float, it's going to be a bool. So what is the difference? We saw that integer or int is basically a whole number. Float is a decimal number. Bool is only true or false. It's just turn on or turn off. And this is going to be accelerate starting at false. So in the beginning, it should not accelerate. All right, so here in the beginning of the update, I'm gonna check if this should accelerate or not. So my accelerate is gonna change to input dot get key down, same thing that we used already. And here I'm gonna use the key code dot arrow down arrow. So every frame, if I press down, this becomes true. If I don't press down, this becomes false. So I can use this accelerate to basically determine if this should fall or not. And now what we can do is basically change this condition a little bit. So instead of always checking the fall time, I'm gonna check 2 things here. If I should accelerate, go faster. If I should not accelerate, go slower. So we're gonna add one instructor here that is called the Ternary Operator. I'm gonna write it and then explain how it works. So the first thing that goes in that is a Boolean, which is our accelerate. And we're gonna ask, is this true or is this false? If it is true, I'm gonna use the fall time divided by, I don't know, let's start with 30, for example. Otherwise, it uses the fall time. So this probably is the most weird thing that you're gonna see today. This is called a ternary operator. The way it works is, it's a ternary because it has 3 terms. The first one is, what is the condition? Should I accelerate or not? If it's true, use this. If it's false, use this. So the question mark is to check if this is true or false. What is before the column is what is executed if it's true. What is after, it's what is executed if it's false. So basically, we are just checking, not against the fall time, but a fall time divided by something that we can change later. Does it make sense? So every time that I press down, it's gonna, oh, no, not this one. I'm lost in my tabs here, found you. So if you make it true, it's gonna keep dropping blocks. Yeah, it's gonna, if we make it true, it's gonna go faster because the fall time is gonna be 30 times smaller. All right, so let's see how it looks like. I'm gonna get default time here to 1 again. And there we go. So if I press down, it's gonna do that a lot faster. So I can control the speed when it goes down. Cool. Is that all right? Is it making sense so far? Nice. What's the difference between using Ternary Operator and an if and else structure? Oh, that's a really good question. The result is the same. So you can do everything that you do with if else with a Ternary Operator. The thing is, the Ternary Operator, it's more useful in situations like this, because if you just want to use an if else here, you need to have a third variable, because I cannot just change default time, otherwise I lose the original. So you can achieve the same thing with both, but sometimes it's better to use a ternary, sometimes it's better to use an if else. So it's gonna depend on what you're doing. Kind of hate using the ternary operator because it's less readable. I totally agree that it's less readable, but here it saves us one variable. So sometimes it's good, but I agree. I don't like it very much too. I avoid using that. Nice. All right. So now, shorter code. Yeah, shorter code is not always the best approach. But anyways, let's keep going. Otherwise, we would not be able to finish this. Now let's make the constraint. I want to make sure that my block cannot go left, right, or down beyond the bounds. So let's do it. First thing, just to have some visual representation here, let me make that align with the grid again. Just to have a visual representation of our background, I'm gonna create a 3D object here that represents the grid. So I will create another cube. I will make that into the 0, 0, 0 for now. And I will scale it to the size of the grid that I want to use. So let's say, for example, that I want a grid that goes from 10 to 20. I'll get my camera and move the camera back a little bit so everything is in the view. But what I did here was basically this. So I created this cube, and this is going to represent our background in there. So it's going to be basically our background in there. One thing that we can try to do here is use the tiles of this grid to determine where I should move or where I should not move. So if I go like left, right, down, or up, where I should stop. One thing that is going to make it easier right now, because I made this background on the 0, 0, X and Y, the center of this object is on the 0, 0. But it's going to be a lot easier for us in a while if this corner here is the 0, 0, 0. So basically what I'm going to do is just move this guy left and up until this is in the corner. So for that, I'm going to just use here 5, which is half of the width, and 10, which is high, which is half of the height in there. And we're going to use that as our visual grid in there. So let me just reposition my camera so I can view that in a better way. Soon we're going to add colors. Let me add colors. Okay, let's add colors, because now it's starting to become a little bit weird, right? When we're looking to this gray and this is super weird. So let's do something here that's going to help us a little bit. So if we want to add colors to stuff in Unity, we need to create what is called a material. So I'll just create a folder here called materials. And under this folder, I will create a new material that I will call, I don't know, white, because it's going to be my background. So I can change the color and then just drag it to the object that I wanna change the color. So I said white, but this is not that white. It's because of the light. All right, we can change that later. And then let's create one blue here to add to the hero cube. I'm gonna create one more material and call it blue. I will change it to blue and drag it to each one of my little blocks there. So that's how we create colors in Unity. And one thing that we need to notice, like this guy here is white, and it's not looking that white because of the lights and everything. So in 3D in Unity, the things are basically shaded by the lights. So we need to change that a little bit, but that's not super important. Anyways, now we have our grid here. We have our dimension, which is basically from 10 in X, 0 to 10 in X, and for 0 to 20 in Y. So the reason why I moved it here to this block is so if I go back here to my slide, I can show you the grid. I know it's super small, but we can consider that every tile is going to be numbered in X and Y. So this is 0, 0, 0, 1, 0, 2, until 0 and with it. That in our case is 10, and to the top the same. So here's going to be 0 and 20. Here's going to be 10 and 20. So every little block here is going to have this value, and we're going to use that to determine if a block should or should not move to a single place. So let's do that in code now. First thing that I want to add here is a variable to represent the dimension. So I'm going to be creating here a private static. I'm going to explain what a static is in a while. Int width equals to, oops, I never write that. I never make that right. Equals to 10. And our height equals to 20. This is basically because that's the size I created here. So if you want a bigger grid, we can basically just create that a little bit bigger. Let me see here. Doesn't matter what order you do the code. Oh yeah, so for variables, not really. You can declare them in any order, but the functions here, yes, they are executed in order. So it does this first, and then this, and then this, and then this. So sometimes it makes, you can have trouble or problems if you change the order. So you need to be careful, but for variables, it doesn't matter. So why I created those two variables as static? We can, for every single block, change the fall time. So we can have blocks that move faster or slower. So when we make variables that are not static, they belong to each specific individual. When we make it static, it's shared across all of the individuals. So the height and the width, or the width and the height, they are shared among all of the game, all of the blocks. That's why I made this static. All right, so now we are gonna check if our move is valid or not. So we wanna check if every time that I make a movement, I wanna verify if that movement is valid or not. So for that, I'm gonna be creating a function. Right now, we only worked with the functions that Unity gave us, the start and the update function. We're gonna create our own function. And instead of being a void, this time it's going to be a bool, and I'll call it is valid movement. Why this is a Boolean? Because I want to tell back to whoever calls this is valid movement if it is valid or not. So it needs to be true or false. So when we have a void function, it means that this function executes code and doesn't give back any value. When I make it a bool, it's going to execute code, and it needs to return a value of this type. So it needs to return either true or false. That's why here it's complaining that I'm not returning anything. So we're going to do that. How I'm going to define if this is a valid movement or not. Every time that any of those small blocks here, if they go below 0 here, or above with it here, or below 0 here or above with it here, it's not a valid movement anymore. So that's what we need to check for each one of the children. Not only one, not only the center, because later on when we delete, we need to check if each one of those are below the grid in there, because it's outside. Exactly. So if it goes outside of the grid, any of those blocks go outside of the grid, we need to make sure that they're not outside of the grid anymore. So that's what I'm gonna do in this function here. And we're gonna learn something that we didn't use yet, which is basically one statement called a for each. Remember that I said that we need to check for each children, for each block, if it's outside of the bound. So we're gonna use a for each block. The way it works is I need to create the type. So I'm gonna check if the transforms, they are outside of not in our transform here. So what this line of code does is for each transform that exists as a child of my own transform, does this thing. So let's go here and see how it would do in the hero. So the hero transform is this. For each transform that exists as a child of hero executes. So it would execute 1, 2, 3, and 4. For the Smashboard, it would execute 1, 2, 3, and 4. So that's basically what the for each does. It repeats this code, giving this condition. Right? So that's what we want to do that. Transform here means visible objects. Yeah, so the transform here means the position, rotation, and scale of each one of the objects. Does that make sense? It doesn't need to be visible. In our case, yes, it is. Are the visible objects here. But, well, if I have like an empty here that is not a child, it's going to be executed there as well. But all right, let's go with that. So in our case, it's the visible one. So what I want to do here is, if any of those are outside of the grid, I'm gonna return that this is not a valid movement. All right. So first thing I'm gonna do is get the X and the Y position of each one of those blocks and see if it's outside of the bounds. But I want to round it because sometimes, for some reason, if this moves just a little bit and then it's not like a perfect round number, I want to make sure that this is rounded. So that's the first thing I'm going to do. I'm going to create here an int rounded X. And then I will get the child dot transform dot position dot X. So I'm just getting like the X position of each one of the child. And I will do the same for Y. That's basically it. But here I want to round it. So I will use a function that exists here, which is the mathf dot round to int. So what it does, instead of round to int, I'm going to use the floor to int that always rounds down. So we have a consistent here. And I will do that with Y as well. So that's basically it. I'm getting where it is in X, where it is in Y, rounding that. So I have something like 0, 1, 2, 3, not like 0.01. Even though the block is not perfectly aligned, that's not going to be a problem here. All right. Cool. So that's it. And I will check if one of those is outside of the bound. So this is quite easy to do. We're going to use an if. And here's going to be, if the round X is smaller than 0, it means that I am outside in the left bound. Or, so this means or, my rounded X is greater than or equals to my width. So because the pivot in the 0, I cannot move past the grid. Same with the Y. So if the rounded Y is greater than 0 or the rounded Y is greater than or equals to the height, in all of those circumstances, I'm going to return false. So what does that mean is, if this happens, this is not a valid movement. So it just returns to whoever calls this function false there. Otherwise, if none of those are false, I return true. So after checking for each one of the blocks, if they are outside of the bounds, if none of them are outside of the bounds, this is gonna finish and then return true, which means that it's a valid movement. Right, so that's quite long, but that's quite logical too. Are the positions of the pivots or the edges of are the positions of the pivot or the edge? Oh, it's the center of each shape. So here, this position is the center of each shape. That's why I am rounding it as well, because it's not going to be exactly 0. It's going to be 0.5 if it's in the center. So rounding, it's going to be 0. It's not the edge, it is the center. Okay? Nice. So now we can use that function that we created to make sure we are not making any crazy movements. So how we can do that, and we're going to need to do that a couple of times every time that we are translating. So let's see how we can use this. Every time that we move, so here in our update, when we move down, for example, we're going to move, oh no, this is the rotate, I'm sorry. This is the rotate, where we are moving down here. So I move down. Every time that I move down, I'm going to check, was this a valid movement? So I'm going to check, is this a valid movement? As we already know, this returns either true or false. So if it returns true, that's okay. I want to know if it's not a valid movement. So the not in C# is this exclamation mark, which means, or it changes the value of the Boolean. So if this returns true, it's going to check if it's not true. So if it's not a valid movement, what do I need to do? Move it back to where it was. So if I was moving that down, I'm going to move that up. I'm going to just move that up. It's like a, oops, you shouldn't be here, move you up. So that's what we do here when moving down. We're going to do that when moving right as well. So I moved. Is this still a valid movement? If it's not a valid movement, I move it left. So it goes back to a valid movement. And I would do the same thing for the left. So after moving left, I'm going to check if this is not a valid movement. What I would do here, move that right. Oops, no, there we go. So I will basically move that right. All right, so this is gonna ensure that we are not moving that outside of the bounds. Why move it back upwards instead of not moving it at all if it's not valid? Believe me or not, that's easier. Moving that back is easier. Because of the rest of the logic and everything. So this is probably the easier approach to explain. Maybe that's not the easier, maybe that's not a more flexible and correct solution, but that's definitely the easier to explain. So just notice that this is one thing, because it's a workshop and I want to make sure that everyone is following along. If you are experienced, you might see some weird things in here that maybe are not going to be the best approach like that we do on our day-to-day, but not moving is okay as well. So let's see if that works when I get back there. So if I get my hero here, we can see that I cannot move it more to the left and I cannot move it more to the right as well. And if I move up, it keeps working right there. Oh, there's a bug here. I should fix that later. Not today, but that's it. So I cannot move it outside of the bounds anymore. And that's basically it. So with this thing, we can basically create as many pieces as we want there. Cool. That's it. So we have all of the basics in there. Because we already have like 1 hour and a half, and I definitely want to go over all of the questions. What I'm gonna do is, well, I will not write every other piece of code from scratch here. I'm gonna get the one that is ready and just go over what are the other portions of the logic, and then, well, we can keep the chat on Slack, but I definitely want to go over all the questions in there. I think there is a lot already here to unpack, and that you can get a grasp of how to work with Unity and how to control game objects in there. So just so we can go to the questions, I'm gonna bring the project that is finalized here and go over what the other steps would be, because now you already know most of the things and how they should work in there. So this is the one that already works with the pieces and whatnot. So we can see that it's spawning a new piece every time that we reach the end. So let's see how I did that. I'm gonna grab the Finalize the Script here. Bear in mind that you're gonna receive this too. So what I'm doing here is every time that, and this is exactly the same code that we have just built, every time that we are moving down, so let's go to the move down here. Where is the move down? Where is the move down? So here, every time that we're moving down, when we realize that this is not a valid position anymore, and we just move that up, so here it's a little bit ugly, but in our case, we're using vector3.up. This is the same thing. Every time that we move up, basically, we're doing two things. So let's just consider this and this for now. We're doing two things. The first thing is basically disabling this script. So when we reach the bottom, I cannot move this piece anymore. So that's the first thing that we do here. So this enable false, just disable this script. So in the next loop, the next update, this is not gonna run and we cannot control that piece anymore. So that's the first thing. And then we ask another script to spawn another new piece. So let's see how this works and why we're using this thing here. I created another object here that is called the spawn manager. This one is another empty game object that just has the spawn manager script. There is another script that we created. This script is very, very similar to the other in terms of structure. The way it works is it has a start, it has an update that is empty, and we created a spawn random piece in here, or a spawn random block, whatever. And what it does is, in the start, it creates a piece. So here we can see that I don't start with a piece. When I hit play, this spawn manager is gonna call the spawn manager script, and the start is automatically called, so it just creates a piece. How does this creating of a piece works? We want to, every time that we hit play, we create a random piece in there. So every time that I hit play, it's gonna create a different piece. Every time that I call this function, it's gonna create a different piece. That's basically how it works in there. To create that random thing, we are using two things here. The first one is a special type of variable that we call an array. So what is an array? It's basically a collection of variables. When we create something like this, we are talking about one piece of data that can only hold one object. When we make it an array with this, now we can hold many objects. And the way it works in Unity is when we have an array, we can say the size of this array, 1, 2, 3, and we can drag different objects here. So we can, for example, drag the hero, the Smashboard, and the tweak. So, and whichever other objects we create there, and all of them are created with the same method, just duplicating the cubes. So when we have them here, we have access to them in the code. So we can access them by indexes. So the one that is here has the index 0. This one has the index 1, and this one has the index 2. And then in this function, spawn random piece, what I'm doing is, First, I want a random object every time. So I need to generate a random index that goes from 0 to the number of elements that I have, right? So the number of elements we can achieve by having a block types.length. So length is the number of elements that we have in there. So every time that we use the random range, it's going to generate for us a number in between the minimum and the maximum. The minimum is inclusive, the maximum is exclusive. So if the length is 3, it's going to generate 0, 1, or 2, which is exactly what we want because our elements are indexed from 0. And then we're going to get a specific piece from that array. So here, the way we index the array is basically using the brackets as well. So we declare that with the brackets and we access that with the brackets. So if I say this, for example, I'm getting the element in the position 0. This is the element in the position 1, and this is the element in the position 2. And I want that in the random position that was generated. So every time that we call spawn random, this is going to get a new value that can be 0, 1, or 2 in our example. If you add more blocks, more elements, it's going to go in between that. And then this is not doing anything. I'm sorry. And then we're going to use an instantiate function. So the instantiate function exists in Unity to create something in the world for us. And we need to pass 2 things. Or actually 3 things. What we want to instantiate. So in this case, is the random piece that we just got, where I'm using whatever this object is, this spawn manager is, and with each rotation. So I'm just using the same rotation of this spawn manager as well. So every time that we call this spawn random piece, it gets a random piece and instantiate that in the position of the spawn manager. So when I hit play, it basically creates 1. If I hit play again, it creates another 1. And when it hits the bottom, it's going to create 1 more. So how does that work? It's basically because here in the piece or the block, we are going to the scene using this find object of type. So when I need to access a function that is in another object, in another script, I need to have access to this script. There are many different ways of doing that. The easiest way to do that is basically just calling this find object of type and the type I want to call. What is the type? It's basically the name of my class. So if this class is called the spawn manager, we want to basically find it and then call the spawn random piece function. One thing that is worth noting here is that we can only call this function because it's public. Remember that I said that private things cannot be accessed from outside of the script. So it's going to start complaining that this is inaccessible because it's private. So that's why now this function needs to be public because we're going to be accessing that from outside of the piece. And that's it. That's why every time that it reaches the bottom, here we know that it hits the bottom, it's going to disable the piece so we cannot move it anymore, and then it's going to create another piece. So that's basically the logic there for creating a different piece. Does it make sense? I see that Ian's typing there. Rebecca's typing as well. I'm just make sure. Great introduction to short scripting. That's good to know. I know it's a lot, but it's definitely an introduction. So surely it is. Amazing. All right. So now the last 2 things that are missing. Oh, actually only, 2 things that are missing. First, I cannot go on top of another piece, right? So if I already have a piece that is positioned here, I cannot go inside of that, right? I need to take that into account. Oh, of course, I commented. I was like, I didn't have this bug before, but I commented the 2 functions that are doing that. So now the 2 things that are missing here that we need to finish, and then we're done. First one is I cannot go on top of other pieces. So if this place is already taken, I cannot place something else there. This is the first thing. So let's see how I am doing that. It's not that complex. So first thing, I created this add to grid function. What does that do? Every time that we hit the bottom, every time that one of our pieces here gets into the bottom, I want to say that this position 0, 0, 0, 1, 1, 0, 1, 1, they are taken. There is something in those positions. I cannot go there anymore. So for that, I needed to first create a structure here that is a matrix of transforms. So we already know what a vector of transforms or an array of transforms is. So it's basically like a collection that has positions 0, 1, 2, and 3 in our case. We can also create multi-dimension arrays. So this here is just telling me that this grid variable is a multi-dimensional array of transforms with 2 dimensions, meaning that we can have 0, 0, 0, 1, 1, 0, 1, 1, and so on and so forth. And then when I create or instantiate this transform here, I'm saying that I have 10 by 20. So I'm just creating a grid that can hold 10 by 20 transforms. Does that make sense? So I know some people are typing there. This is quite complex, so let me just make sure you get it. Just thumbs up, thumbs down, thumbs up. Great. Cool. And then every time that we position our pieces in the bottom, I'm gonna add them to this grid. How I do that? I created this function add to grid that I'm calling here every time that I hit the bottom. I call this add to grid, and this is pretty straightforward. Basically what it does is, so with this, you're trying to say that as the block hit the bottom, they will sort of become part of it. So no block. Yeah, exactly. That's exactly it. So every time that they hit the bottom, not necessarily the bottom, like when they are set, when they cannot move anymore, we're going to say that they are part of this grid. That's exactly it. So we created this logical grid here that can hold 10 by 20 elements. And right now it's empty. It just has like 10 by 20 slots, but nothing are on those slots. And we're going to add them on this add to grid every time that it cannot move down anymore. So if I cannot move down, I'm trying to move down. I cannot move down. I move back, and then we add them to the grid. In this add to the grid, what I'm going to be doing is, we are familiar with the for each again. I'm gonna go in every smaller block that compounds or that makes the piece, because here, for example, I need to add, when this hits the bottom, I need to add every single tiny block to the grid. So that's why we make the for each here. For each one of the small blocks, we get the position where they are and round it again, so I can know if they are in the 0, 0, 0, 1, 0, 2, and I add them to the grid in the exactly same position. So say, for example, here in this case, let me find a simpler case here, which is basically adding this block here. So now this is in the 0, 0, 0, 1, 1, 0, 1, 1, right? We have even the drawing here, 0, 0, 0, 1, 1, 0, 1, 1. So what I'm doing is, all right, this is not empty anymore. Now it has that specific block that I am checking. So every time I add that to the grid. Every time that I cannot move down, I add all of the small blocks to the grid. And now, for the blocks not to overlap, I'm going to modify the valid position a little bit. So what we were doing is, if it's outside of the bounds, we just don't let it move, or we move it back, right? Now we're going to add one more condition, that if there is something there, it's also not valid anymore. So I'm going to check, okay, I'm trying to go to the position 0, 0. If it's not null, what does null mean? Empty. So if I check if it's null, I'm checking, is it empty? But I want to check, is it not empty? If it's not empty, it means that I cannot move there. So now in our valid position, we have one more line, which is basically telling us, hey, if there's something there, you cannot move there. And we don't need to change anything else because this function is already being called in the correct positions. So now we add to the grid every time that we cannot move down anymore, and we check if there is something in that position in the grid. All right? This makes sense? And last but not least, the last thing is, how do I check if I have a complete line in the end? If every time that I complete a line, I destroy it and I move everyone down. Let me see if I can do it. So we can see the behavior. Oh, there we go. So it basically removes the line and moves everyone down. Let's see how I'm doing that. It's not that complex. So every time that we add everyone to the grid, we cannot move down anymore. I'm calling this function process lines that we created. So I just created this function that I called process lines. And this function does three different things. And I will explain what they are in a while. So it's gonna first go throughout our entire grid from the bottom to the top. So here I'm using a for loop. How does a for loop work? It just repeats a condition, just repeats some code, and we have three parts to it. So the first one is, where does it start? So if my grid has a height of 20, it's gonna start in 19, and it's gonna go 19, 18, 17, 16. That's why we have the row minus minus here. So the for it works like where I start, when do I stop, and how do I move? That's basically how a for loop works. So here I am starting at the height minus 1, moving one by one down, and then when it reaches 0, I stop. Basically, what I'm doing is just going through the entire grid row by row. I'm just going this row, 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 this row. So we know that we want to check all of the rows in there. So that's what we're doing here, checking all of the rows. For each one of the rows, we're going to check, is this complete? If this is complete, I delete that specific row, and then I move that entire row down. All right, so I'm going line by line in the grid, checking, is this line full? If it is, I delete that line and I move everyone down. Okay? So maybe this is a little bit cryptic, but what the for does is basically repeating from one value to the other. So it's repeating from the height minus 1, 19, 18, 17, until it is 0, one by one. So row minus minus is the same as row equals to row minus 1. So basically how we move in there. All right, so now let's see what those three functions do, and they're the last one. So the is line full, it's quite straightforward. I'm passing a number of a line and checking, is this line full? So let's see how it works. I have this line or this row here. I'm gonna go column by column and see if that column is empty or not. Why column? So I'm checking if this row here is fulfilled or not, if this entire row here is empty or not. So the row is 0. So I'm gonna check, is the row 0, column 0 empty? What about the row 0, column 1? What about the row 0, column 2? And so on and so forth. So basically, that's why we receive the row, and we're gonna check column by column. So here our for is going from 0 to the number of columns that we have. So it's gonna go, say for example, the row is 0. So it's gonna test 0 against 0, increment 1, 0 against 1, increment 1, 0 against 2, increment 1, until the column is the last one, until it is 9. So we're gonna check the entire line row by row. Is this null, meaning that it is empty? If it's empty, I return false. It's not full. If it's empty, it means that there's not a block there. So I should not do anything. I only do something when all of the columns in that row are not empty. Does it make sense? So this is the first thing. We're going to check if the entire row, column by column, is empty or not. If one of them is not empty, we return false. It's not a full line. All right. So that's the first thing in the line full in the process line here. For each one of the columns or the rows, actually, we check column by column to see if it is full. Does it make sense? Nice. And then we move forward to delete the line, which is basically making sure that we don't have those blocks anymore. For that, we need to do two things. So for our old friend here, we're going to do that again, like column by column in that row. We're going to destroy the block. So the destroy function is a Unity function that just destroys a game object. So we're destroying the block. So visually, that block disappears. But we also need to logically remove it from the grid. So we just say that the element in that column row, now it's new because I destroyed it. So that's what deletes it. Deletes it visually, deletes it logically from the grid. So now I can place something again there. So now it's deleted. And last, I need to move everyone down, right? So let's see what the move down does. Very similar. We have another 4, but now we need to move the entire grid 4 down. So we're gonna do a 4 inside of another 4. Why? This is gonna go from 0 to height. This is gonna go from 0 to width. So it's gonna repeat 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3. That's why we have like one for the lines, one for the columns. We need to move everyone down. We're gonna check, is this element in the grid X and Y here that we have? So 0, 0, is it not null? Is there something there? I need to move it down. 0, 1, is there something there? I need to move it down. 0, 2, is there something there? I need to move it down. So every block that is not empty in the grid, we need to move that down. That's why we go over the entire board, the entire grid, check if everyone is not null, and then we move that down. How do we move that down? First, we need to update the grid logically. So the guy that was on the 1, 1, for example, he needs to go down. So he goes to the 1, 0. That's why I make the y minus 1 here. So I'm making that down logically. If it was 5, now it goes to the 4. If it was 10, now it goes to the 9. So that's the first thing. I move the block down logically. Then the guy that was on top, now it's empty because I moved that down. So we move this guy down. We make the one that was on the top null, and we translate it visually, which you already know. So now the guy that was logically moved down, we make it go down visually as well using the translate. So that's why everyone moves down logically as well. And that's it. That's the simplest logic for Tetris. If you look into the wikis and it's a half player, you're gonna see there's a lot of other things that we can check, specials, combos. How do you end the game? I don't. In this demo, I don't end the game. How you could end the game here, and that's gonna be my challenge for you. In the valid movement here, if you go to the valid pause, we're checking if the y is greater than the height. So when that happens, it means that we have a block on top. So you can keep adding to here more logic to determine when the game ends. I didn't do that, but you can do position. If like everyone on the top line, I don't know what is the logic exactly. It's anyone goes up, like if any block goes, the game ends. If it is like any block goes outside of the board on top, if ends, it's basically this. If any object here is greater than the height, it means that I have one object outside of the grid. So from here, you can derive a couple of challenges. You're gonna receive the GitHub repo in there with everything, so you can keep moving. We're gonna create a Slack channel just for this project. If you have questions and you want my help, feel free to go there and talk to me directly. I'm gonna be happy to help. So I'm gonna invite Kyle back here. He's gonna kill me because it's super late there. I'm so sorry.
Jerry, I don't mind how late it is. What the trouble is our recording ends right at 2 hours, so we're on the button right now. Folks, if you've made it this far, we are officially 2 hours in. I really appreciate all of you sticking around. I have a bit of a slides that I'm not actually going to show right now. We don't have time, and unfortunately we do need to cancel the Q&A as well. There are 3 things that I want to leave you with. The first is actually an ask. I'm going to publish the poll right now. So if everybody can navigate on over to the polls tab, it's quite simple. On a scale of 1 to 10, how likely are you to recommend this workshop to a friend? Like I said off the top, this one helps us a ton. It helps us to determine what type of workshops we should be teaching, how we did today, all of that fun stuff. So please take just a second, leave your feedback there. It really, really helps us out a ton, and it's totally anonymous. Once again, that was recorded. We are going to be sending out the GitHub repo. My colleague Dayon, who you've seen in the chat, it should go out in, I'm going to imagine, about an hour or 2. You'll get the repo with the completed project, all of the scripts and the assets, as well as the recording to follow it along with. We make really, really cool projects in all of our courses. We have some amazing students who, like you guys today in the audience, are coming as a beginner. We would love to have you guys join our programs. Again, we offer 3 main courses. One builds off of almost exactly what we taught today, the Intro to Unity Development. It's an 8-week course. It's taught totally live, totally online. It is project-based. Everything is recorded. You get to keep everything in the course, and you get lifetime access to join our community, which is run by Lucy, who is absolutely fantastic. She will take care of you, I promise. We also have the XR development and the interaction design courses. These are deep dives into virtual and augmented reality within Unity specifically. So one, as the name would suggest, focuses on developing VR and AR content from scratch, while the other focuses on the best practices for designing XR content in Unity for the designers in the room. Now, the XR Development with Unity course is also offered by our 4 university partners. We do have cohorts all around North America, and we will be launching more partnerships early on in 2022 as well. The other thing that I will leave everyone with is Black Friday. We are currently offering an epic sale on a first come, first served basis, or until Cyber Monday, which I believe is Monday, November the 29th this year, whichever comes first. What we're currently offering is 50% off of either our starter or plus packages for the XR development and XR design courses. And because it's the inaugural cohort for our our Intro to Unity Development course, we're actually offering 50% off of that course. My colleague Dayon is sharing all of the deals information right now. Feel free to log on to our website to check out a syllabus, to submit an application to learn more. The last thing I'll leave you with is that, unfortunately, due to the nature of our agreements with the universities, we cannot offer those on a discount. So you do have a choice to make. You're welcome to do, obviously, our university courses through our partners, or to learn directly with CircuitStream and to take advantage of the sale while it lasts. I think that's everything. We're going to pause it there. We're well over 2 hours at this point. But once again, I do want to say thank you all for attending. Have a great rest of your evening, morning, afternoon, wherever you are in the world. It's a pleasure, as always, to be hosting these workshops. And good night. Thank you very much. Bye-bye.